So this problem asks us to use a quadratic formula to find all the degree solutions and theta if theta is between 0 and 360 degrees, and it says to use a calculator to approximate all answers to the nearest tenth of a degree. So in order to use the quadratic formula, the first thing we're going to do is put this in the ax squared plus bx plus c form. So that means that I have to set this right side equal to 0 by subtracting 9 sine theta from both sides. So then my equation will look like this. And now I'm in that quadratic general form that is like this so that I can use the quadratic formula. Now, our x's here are sine. So we have sine squared here and sine. This is a quadratic equation. And so my a, I'm going to identify my a, b, and c here. My a is 5. It's the coefficient on sine squared. My b is -9. It's the coefficient on sine theta. And my c is the constant by itself, or 1. And so to use the quadratic formula, I have to first write it here. It's the opposite of b, plus or minus b squared minus 4ac. That whole thing divided by 2a. So all I have to do is substitute in these three values in the appropriate places here. So it's the opposite of -9, plus or minus the square root of -9 squared minus 4 times 5 times 1. This whole thing divided by 2 times 5. Now, it's very important right here that you surround this with parentheses because it's -9 squared. So when you put it in the calculator, I want to make sure that you do that because the opposite of 9 squared is different than -9 squared. So very important there to surround that with parentheses. So now I can put this in my calculator in this right here, or I could choose to simplify a little bit before I get there and put in my calculator. This is the opposite of -9, so +9. In the denominator here, I have 10. 2 times 5 is 10. This will be plus or minus 81 minus 20. So I have 9 plus or minus the square root of 61 over 10. So this would be the exact answer, and I would check if I could simplify the square root of 61 further. But the question does not ask for this. It asks us to put it into a decimal rounded to the 10th place. So let's do that. And so I'm going to grab my calculator. I'm going to bring it over here. And I'm going to put in what I just had on the screen here. So I'll have 9, and I have two values here. I have 9 plus the square root of 61 divided by 10, and I have 9 minus. So I'm going to write 9 plus the square root of 61. And like I said, you could put this in as it was up here, so that you can do it all like that, just making sure you surround the numerator with parentheses. And then I'm going to do divide by 10. And so this will be one of my answers. And then I'm going to go and I'm going to do the same, but I'm going to switch this to minus. And I get 0.11. Now I'm going to go put those two answers on my calculator, or on the paper. 1.681 and 0.11898. So those are my two answers. But these two answers that I get, what do they mean in terms of my problem? So they mean that I have gotten the value of sine. So this is telling me that sine of theta is equal to 1.6810, and sine of theta is equal to 0.11898. And yes, I shouldn't really round here. I'm going to keep it as long as I can. I did round a little bit. And so the first one here, sine of theta, what we're looking for, we want to find theta. Remember what the problem said is to find all degree solutions and theta if theta is between 0 and 360 degrees. And so I am looking for the angle. And that quadratic formula, or if you had factored, I mean, we couldn't factor this one, it doesn't factor across the integers, but gives me the trig function value, and I'm looking for the angle. So this first one here is not possible. It is outside of the range of sine. Remember, sine, when you look at it, it only goes between -1 and +1. And this right here, so I'm going to say the trig function value is between -1 and +1. This is outside of that. So this I can rule out. That is not a possible trig function value, so I can't find theta here. And remember, how do we find this? We put it in our calculator and we say theta is equal to the inverse sine of 0.11898. So if you forgot that this was outside of the range, when you put it in the calculator, it will give you an error. Let me show you what happens. So when you do second sine of 1.681, you're going to get this, and it says it's not in that domain. So if we go back here and we do second sine, but now this time of the other one, and I have it written out all here, so I'm just going to put it in as I see it. And now this returns, oops, actually, you have to be in degree mode. So go to degree mode. I forgot this calculator is always resetting. So let me do second entry. All right, now we're going to get the right answer. Here is 6.83. Now, remember that in this is between 0 and 360. We have seen that you're going to have some values that, repeat themselves. So 6.8 degrees, this is in quadrant 1, gives a trig function value of 0.11898, but there is also a trig function value of that in quadrant 2, 3, and 4, but only positive in quadrant 1 and 2. It will be negative 0.11898 here, and it'll be negative 0.11898 here. So we're not interested in quadrant 3 or 4, because these are negative, and this value is positive here. So I'm going to say, all right, I can ignore quadrant 3 and 4, but I need to find whatever angle this is here. And in order to find that, we know 6.8 is the reference angle. and we called it theta hat. So in quadrant 1, the reference angle is just equal to the angle. So in quadrant 1, it's 6.8 degrees. So that's one of our answers. And then in quadrant 2, the formula for the reference angle was theta hat is equal to 180 minus the angle. I'm writing this backwards. Hold on. Theta is equal to theta hat. Theta in quadrant 2 is equal to 180 minus theta hat. So in quadrant 2, we'll take 180 and we'll subtract 6.8 degrees, and then we'll end up with 173.2 degrees. So in quadrant 2, it's 173.2 degrees. So here are my two answers. So in part B of the question, it asks for the angles between 0 and 360, and those are the two answers it's looking for. And then in part A, it says, well, all the degree solutions, and let K be any integer. So you have to take 6.8, and then you're going to find all the coterminal angles. To find the coterminal angles, you take 360 degrees and you multiply it by K. So that'll be 1. And then the other one will be all the coterminal angles with 173.2 degrees. And you have to use the variable K because it tells you to use K for any integer. So this will generate, when you put in -1, 0, 1, 2, 3, all the way to infinity, it's going to generate all the angles that are coterminal at 6.8. And this one will generate all the angles that are coterminal with 173.2 degrees. So this is for all. So in part A, all degree solutions. And for part B, between 0 and 360, it's just these two. So that is how to do that question that comes from 6.1.